Swayam Prabha. Digital India. Educated India.
Welcome back to the last lecture of this module. We concluded at the similitude last time, where we discussed the dynamic similarity, okay, and we start with the extension of similitude, that is model scales. So, the fluid flow models are usually designed for one most dominant force and occasionally for two. Okay. Suppose if the dominant force here is gravity, then Froude number must be the same in model and prototype. Okay. If the dominant force is viscous force, then Reynolds number must be the same in model and prototype. Okay. So, we start by solving a problem. The question is, for Froude model law, find the ratios of velocity, discharge, force, work and power in terms of length scale. Okay. So, the way the solution will grow, so in Froude model law, the model and prototype Froude numbers are the same, correct? That is why it is called the Froude model law. So, Froude in the model M, FRM will be Vm by under root GLM should be equal to Froude number of prototype is equal to velocity in prototype by under root GLP. Okay. So, very simple. So, if we bring, it will be Vm by Vp is equal to under root Lm by Lp. G will get cancelled, right? Anyways, for now I will take away this. So, gravity G is same for both model and prototype. Hence, if the length ratio Lm by Lp is Lr, what we said here was Vm by Vp is equal to under root Lm by Lp, okay, and yeah, all right. So, the velocity ratio Vr will be under root Lr, correct. So, this is what we get. We have done the same thing here, okay, by pen. Now, the discharge ratio Q. So, discharge ratio Q will be the ratios of velocity into area, okay, all right. So, I will just, so velocity is given by Vr and area is the length, the length whole square. So, Vr we have already found out that Vr was Lr to the power half in the previous slide multiplied by Lr square. So, it becomes Lr to the power 5 by 2 as indicated here, all right. Force ratio will be the ratio of densities multiplied by Lr square into velocity square. So, ratio of densities we said was rho r into Lr square, and Vr was under root Lr whole square. So, it will be rho r Lr cube, but anyways I will take this down myself, alright. So, force ratio is going to be rho r Lr cube as we just derived. What about the energy ratio? Energy ratio is force into distance. So, F r into L r, so it becomes rho r L r to the power 4. Okay. So, rho r into L r to the power 4. Now, power is force into velocity. So, it is force ratio into V r. So, it is force is rho r L r cube into V r is under root L r. So, it becomes rho r L r to the power 7 by 2. All right. So, same thing, rho r into L r to the power 7 by 2. All right. Now, there are something called distorted models. Those were an example with proper modeling, where all the laws were taken into account. There are something called distorted models. So, idea behind similitude is that we simply equate all pi terms, correct, but in reality it is not always possible to satisfy all the known requirements so as to be able to equate all pi terms. In reality, it becomes very difficult to equate all these terms. Example, study of open channel or free surface flow. We will see through an example. So, in this case, the Froude number similarity will give Vm by under root Gm Lm is equal to Vp under root Gp Lp, right. And if we have the same gravitational field just considering, this will give Vm by Vp. So, the ratio of the velocity will be lambda, so under root of length ratio, that we have seen in the previous example, correct. So, under root of length ratio, fine. Now, we if because both Froude number and Reynolds number should be the same, if we do the Froude Reynolds number stability, we will have Reynolds number equated for the model Reynolds number, and this is prototype Reynolds number. Okay. So, based on that, the velocity scale is going to be Vm by Vp will be mu m by mu p into rho p by rho m into Lp by Lm. So, we bring Vp down here and take other terms that side. Okay. Since velocity scale must be equal to lambda r, okay, so we will equate this to lambda r, fine, and this is already lambda r. So, ratio of kinematic viscosity is going to be mu m by rho m by mu p by rho p is equal to nu m by rho p is equal to, this will come this side because this was lambda r to the power half, right, and this was here. So, it becomes lambda r to the power 3 by 2. And in reality, it is very difficult to find such liquids that satisfy the above relation. So, it might not be always possible to find the fluids having this viscosity ratio. So, in practical, ideally if we can have all the type of similarities, that is the best case solution, but in reality it might not be always I mean we might not be able to find it all the time. So, to overcome difficulties like before modeling, I mean the one that we did, we use distorted scales or distorted models. So, what is done here? In open channel, the vertical dimension is used to simulate Froude laws, while the other two dimensions are scaled to suit the available space. So, in Froude law, in Froude number, the vertical dimension, so basically for Froude law we use only the vertical dimensional scaling, and for the other two dimension x and y we use the geometric scaling, for example. So, in distorted scale models, horizontal scale length and width is given by LR. A vertical scale can be different. In this case, it can be HR. Now, ideally, LR should be equal to HR, but in distorted models, we do not do that. All right. Cross sectional area will be the area in the model divided by area in the prototype, correct? If we try to calculate the cross sectional area. So, it will be width into y divided by b into yp, correct? All right. So, width of model by width by prototype is given by the length ratio, right, whereas the vertical cross section ym by yp is given by hr. So, cross sectional is given by LR into HR area. All right. So, it is not LR square, it is LR into HR. Froude number ratio is 1, correct. So, this give us Fm by Fp is equal to 1, and this is Vm. So, correct, that is what it means, Fr is equal to 1. So, through this, so implies Vm by Vp is equal to under root Ym by Yp, and what is the ratio of Ym by Yp is HR. So, it is under root HR, but anyways we will see. Okay. So, Vm by Vp whole square by Ym by Yp is equal to Vr square by HR, another way of solving, and we get the same result. So, the velocity ratio is under root of HR. Okay. Discharge ratio is area ratio into velocity ratio. Area ratio was LR HR into velocity ratio is HR to the power half. So, it becomes LR into HR to the power 3 by 2. Slope ratio is Sm by Sp is equal to, it is y by x, right. So, it is HR by LR, one side is the depth, one is the x and y dimensions. Time ratio is LR by VR. So, LR is LR and VR is under root HR. So, it becomes LR divided by under root HR. So, for distorted models find So, for distorted models find Manning's ratio NR. This is a homework problem for you. So, you can find and post your solutions in the forum. All right. So, For distorted models only you have to find the Manning's ratio. It's very simple. If you know the Manning's number formula, you will just look it up. Okay. So, we are going to solve one problem. In a tidal model, it is given that the horizontal scale ratio is 1 by 500. So, horizontal scale ratio is LR is 1 by 500 and the vertical scale is, so that means HR is 1 by 50. What model period would correspond to a prototype period of 12 hours? Very good question, and we will see how do we solve this problem. So, horizontal, as I wrote, horizontal scale LR is given by 1 by 500 and vertical scale HR is given by 1 by 50. So, time ratio is LR by under root HR. We can also see that from the previous slide formula, right, for distorted previous slide formula. Okay. So, it is LR by under root HR. LR ratio is 1 by 500 and HR is under root HR is 1 by 50. So, this comes out to be 0.01414. Okay. Now, the time ratio is given by Tm by Tp and this Tr we already know, and it says that the prototype period of 12 hours, which implies Tm will be Tp into Tr. Prototype is 12 hours into 60 minutes into 60 seconds multiplied by Tr, Tp in seconds, and this when you multiply it will give model time period of almost 610 seconds. So, this means a model second of 610 seconds would correspond to a prototype period of 12 hours in a tidal model. All right. So, this is the problem that we have seen now. So, after that we are going to solve some problems that relates to these similitude and model scale, some more problems. So, first problem which we have already actually done in dimensional analysis. So, we go to problem number 2. What does it say? It says that a model boat 1 by 100 size of its prototype has 0.12 Newton of resistance when simulating a speed of 5 meters per second of the prototype. Water is the fluid in both the cases. What is the corresponding resistance in the prototype? We can actually neglect the frictional forces. Okay. So, we will start as always. So, this is question number 2. We are going to the white screen. Okay. So, the resistance offered at the free surface is the significant force and as such Froude model law is applicable. Okay, correct. So, Froude model law FRM is Vm under root GLm is equal to Vp GLP is equal to Froude number in prototype. Okay. LR is LM by LP and VR is going to be under root LR, that we have already seen using the Froude model law. Okay. And force by model by force by prototype came out to be rho r LR square. If you remember the formula, it will be rho r LR cube. Okay. So, since same fluid is there, therefore, rho r is equal to 1. This implies Fr is Lr whole cube, or in other terms, for Fm by Fp is equal to Lr cube. All right. So, Fp in prototype, force in model divided by Lr cube. Now, we substitute the values. Fm is 0.12 Newton and this is 1 by 100th Lr. So, this is going to be 120,000 Newton or 120 kilonewton. So, force in prototype is going to be 120 kilonewton. This is the answer. So, here you have seen how we have applied this model similitude to obtain the force in the prototype. All right. So, we will solve another problem, problem number 5. Okay. This is on the same concept. So, the question here states a proposed model of a river stretch of 15 kilometer is to have horizontal scale of 1 by 200 and a vertical scale of 1 by 400. What does this question say? I mean, what does this indicate? This indicates that we are dealing with distorted scales, because we have a different vertical scale, a different we have a different horizontal scale and a different vertical scale. All right. So, proceeding back to the reading the question, if the normal discharge width and depth of the river are 152 meter cube per second, 90 meter and 2 meters. So, discharge is 152 meter cube per second, width is 90 meter and depth is around 2 meter. Okay. We have to estimate the corresponding model quantities. Okay. What value of Manning's roughness n is to be provided in the model to represent a prototype roughness value of 0.025. So, basically this question will demonstrate all the distorted scale, including the Manning's roughness question that I gave you to solve at home. Okay. So, to solve that, I will go to the white screen. So, I will just write solution 5 here. So, we have been given, so I will just draw a line here as well. A horizontal scale LR is 1 by 200. Vertical scale HR is 1 by 40. Okay, that's the question. Right, so first thing to solve is discharge. So Qm by Qp, we have already found out it was Lr into Hr to the power 3 by 2. So implies Qm is going to be Qp into Lr into Hr to the power 3 by 2. And Qp is 152 meter cube per second multiplied by 1 by 200, and Hr is 1 by 40 to the power 1.5, and this will give 0.03 meter cube per second in model. All right. Second thing is depth. Ym by Yp is Hr, correct? Simple. So this implies Ym is equal to y into Hr, or Yp here given is, so Yp the depth was actually, so I should have actually first, okay. So I will also write down the known quantities. Sorry for this, I will write down the known quantities here. So Q prototype was given as 152 meter cube per second. Width was given as 90 meter, and Yp was given as 2 meter. No. Right. Right. So Yp was 2 meter into Hr was 1 by 40, and it comes out to be 0.05 meter. So that means in model it is 0.05 meter Ym, and Qm was 0.03 meter cube per second. Now the third thing is width Bm, right? We have to find. So Bm by Bp is the length ratio, right? So this implies Bm is, so width is Bp basically, okay. So Bm is Lr into Bp. All right. So Lr was 1 by 200 into Bp was 90 meter. So Bm comes out to be 0.045 meter. So now Manning's N. This is important. So Manning's Nm by Np, you have to find out the formula, but it comes out to be Hr to the power 2 by 3 divided by Lr to the power half. Okay. This implies model Nm is Manning's number in prototype into Hr to the power 2 by 3 Lr to the power half. So in the known quantities, we were also told the prototype roughness was given, that was 0.025. So this is 0.025 into HR was 1 by 40 to the power 2 by 3 divided by 1 by 200 to the power half. Alright, so eta m comes out to be 0.03. Okay. So, prototype roughness was 0.025 and the model roughness is 0.03. So, model here has to be rougher than the prototype. Okay. So, if we have seen that everything is reducing, the discharge in model has reduced, the y has reduced, okay, the depth, the width has reduced, but the special thing to note is that the Manning's n or the roughness. So, model here has to be more rough than the prototype. It is an interesting result, some things to ponder over, and with this, I would like to finish this module. We have some more questions, but we can take it up in either forum if you have come up with anything else or in the assignments that we are given. So, thank you so much for attending this module. I will see you in the next week.